Welcome to the channel. Today we'll be solving LeetCode question number 518 and it is marked medium. You are given an integer array of coins representing coins of different denominations and an integer amount representing a total amount of money. Return the number of combinations, this is a keyword and we'll get back to it, that make up that amount. If that amount of money cannot be made by any combination, return 0. You may assume that you have an infinite number of each kind of coin. This line means, say, the array we are given is 1, 2, 3. Okay, this means that we have a coin of 1, coin of 2, and coin of 3, right? Coin of value 1, 2, and 3. This line means that each coin is available in an infinite number. That means we have 1, 1, 1, 1, 1 to infinity, that much amount of one value coin, and that is true for each of the other denominations as well, right? Now say an example is 1, 2, and 5, and the amount we have to make is 5, right? Let's first understand what this combination word means. So in this question, by combination they mean that how can we make 5 using these numbers? One way is 1 plus 2 plus 1 plus 1, right? This is one of the way. Another way is 1 plus 1 plus 1 plus 2, right? But if you notice, there are 3 ones here and 1 2, and here also there are 3 ones and 1 2, right? So in a way they both represent the same thing, right? So this is called a combination. That means we cannot count it twice, right? They both represent the same thing, and hence the count will not be 2 but 1. This is one of the way of making a 5 using these coins, right? That is the meaning of a combination. Now how do we make sure that if we have already counted this one, we do not again count this one? How do we make sure of that, right? Let's see that. So okay, so I can make 5 equal to 5, right? I can make 5 and we have 1, 2, and 5. I can make 5 by 1 plus 1 plus 1 plus 1 plus 1. This is one of the way, right? The other way would be 1 plus 1 plus 1 plus 2, right? Let's keep doing this and try to find the pattern. The next way could be 1 plus 2 plus 2, right? And the last way could be using the 5 itself, right? These are all the way we can make a 5 using these coins. Now if you see a pattern, it is that we have used 1 all the way here. In this one we have used 1 till here. Here we have used 1 till here, and here we have not used 1 at all. What can you say about that? What we realize from this pattern is that once we have stopped using 1, we are never using it again, right? We have never used 1 after this one, right? We have not done 1 plus 2 plus 1 plus 1, right? This is the wrong way. I mean, not the wrong way, but for our question this is the wrong way, right? So how do we ensure that two similar combinations never appear twice? By making sure that a single number is not used after we move on from it, right? So our logic of solving this question is Start by using the maximum number of times you can, and after you have used all of it, don't use it ever again, right? The maximum number of times I can use 1 is 5 times to make a 5, right? Then we can use it a maximum of 3 times and then a maximum of 1 time, right? So if we have used 1 and we are moving from 1 to another number, say 2, after this we'll never use 1 again. So that's how we'll ensure that patterns are not repeated, right? The combinations are not repeated. Now let's see how we actually solve this question. So we have a coins array 1, 2 and 5, right? We want to make an amount equal to 5, right? We can solve this using recursion or dynamic programming, right? So what would our call be? As I said, we have to ensure that we will never return to a number after we have used it, right? So that means either we will use a number or we'll move on from it, right? We'll never see it again after we move on, right? So every DFS call, the call would be something like this. It will have the index and the remaining amount that is left. Okay, so let's say we have used 1, we have used 1 again, and we have used 1 again, right? At this moment, the amount remaining for us would be, like calling after this, amount remaining would be 2, right? And the index would be 0. Why? Because we have only used 1 till now. That means we have never left the 0th index, right? So that means at this point we have two options, right? We have two options. Either we keep on using 1, that means add another 1 to it, right? We can do that. If we do that, the next call would be 0. It will remain same because we have not moved on from 1 yet, and the amount will reduce by 1. That means 2 becomes 1, right? Or what we can do is, instead of adding 1 here, we can add a 2. That would make us 5, right? That would make a 5. So here what we can do is, we moved on from 0th index to first index, and the remaining is still 3. Why have we not subtracted 2 from here? Because in this call we will decide that. In this call again we have two options of using 2, right? We can either use 2 or we will not use 2. So we'll decide that in this call, not in this call. In this call we just moved on from 0th index to the first index. After moving to the first index, we'll decide if we want to use that number or not, right? So the DFS call can be written as something like this. At every step, what we can call is DFS of IDX current index. That means we are using the current index like this. The index does not change, right? But what changes? The amount, remaining amount. So remaining becomes remaining minus the value present at IDX. This is one of the call, right? And the other call is DFS of IDX plus 1. That means we are moving on from the current index and the remaining remains the same, right? After this call we'll decide if we want to use the next index or not, right? So it's on the next call, not in this one. So that's why remaining remains the same for this call, right? Now what's the actual answer for it? The actual answer is the sum of both these ways, right? The number of ways we can make 5 by following this path, and the number of ways we can make a 5 by following this path, the sum of that will be our answer, right? We'll have to add both the numbers, and that will be the total number of ways we can make 5. Okay, so let's code this out. The code is very simple. This was the logic, and the logic, the important part in the logic was understanding what combination means and how to solve for it, right? Let's write a dfs call. So func dfs will take the index, as I said. It will take a remaining amount, which will be int, and we take the coins array and will return an int. So the answer we were looking for is, as I said, answer equal to dfs of I comma remaining minus coins of I plus dfs of I plus 1 comma remaining, right? And we return answer. Now we need a terminating condition to stop the recursion as well, and the obvious terminating condition would be if I is equal to length of coins or remaining is less than 0, we return 0, right? And before that one, if we have reached the answer, if remaining is exactly equal to 0, then we'll return 1, right? We have found one of the ways to make the amount using the numbers, right? That's why we have reached a 0. Otherwise we would have reached a negative number, right? Say we are using something like 1. Say we are using something like 1 plus 1 plus 1 plus 1, and at this point we choose a plus 2. That would mean we have reached 4 plus 2 6, and remember we were subtracting as we selected a number, right? So that means we would have subtracted 5 minus 6 and minus 1. So this is not a valid way, and then we'll return a 0 for this case. Let's try calling this return dfs of, it will start from the 0th index, remaining will be equal to amount at the starting, and we'll pass the coins. Let's see if it runs or not. Okay, we have to pass the coins, right? Yeah, it's running, but it will give a time limit exceeded error, so we need to memoize it, right? So for memoization we'll use memo equal to make map of int to int, right? And we'll pass the memo as well. One, two, three. Now we have to make the key for this. So key equal to I comma remaining, right? And we'll check if val okay memo of key. If the answer already exists, then we'll return val, otherwise we'll store the answer, right? Here memo of key equal to answer. It will be memo here, and we need to pass memo now. And it's working, I think. And we have passed the test cases. Nice. This was the solution for this question, and I'll see you in the next one.